what we are building, what can go wrong, what they're going to do about it, and what can we learn from it. So if you take all these 4 questions, and for whatever you are building, try to address those, it's already a very good first step. Kind of easy to memorize, to get started, separate 1 hour meeting to address these things, identify the potential threats, and then do something about them. That's the very beginning of that.
And then you mentioned that you found in production the a critical SQL injection just because some limitation in the characters, and probably when you mess up with this, you can just exploit the table or do some other messy things, right? Hello and welcome to Dev Academy podcast, your gateway to the insights and wisdom of prominent experts and engineers from around the globe. I'm your host, Bartosz from Dev Academy, and it's my mission to help you glean insightful knowledge from the vast experiences of our distinguished guests. Each week, we will delve into timeless topics in software development, focusing on crucial areas like security, quality, and design. Join us as we unravel the complexities of software engineering, offering you a practical, in-depth perspective. Let's embark on this enlightening journey together and transform the way we create and understand software. Today we have Anderson Dadario. He is a founder of DevOps.security, a secure by design platform for developers. He worked as a developer and product security engineer over the years since 2005. Starting as a software engineer and specializing in application security, especially threat modeling, gave him a deep understanding of the secure software development process with the lurking risks alongside with battle-proven mitigation techniques. I guess it's going to be extremely interesting to talk about your expertise and experience in terms of software development and application security. Do you agree with me?
We'll see by the end of the video how well I can... or cannot talk about this thing.
Sure.
No, I'm just kidding.
Don't worry. I think I'm really happy to have you on the show. So Anderson, could you give us a bit about your journey in the tech industry? As we know, it started in 2015. 2005. Sorry, it started in 2005. And especially, I'm interested in your focus on web security and web development.
Right. So, as I guess most of the people here are developers, I assume. So I started as a developer as well. So back then it was a webmaster, right? Sounds so fancy. Webmaster, and started reading whatever you could find on the internet. It was very hard to find proper ways to learn. Back then it was JavaScript, PHP was pretty easier to get started compared to other languages. There wasn't that many resources. But I always developed some interest in security, right? It was always mystical how websites could be compromised, this kind of thing. Then you start to go into Google and search back then how security works. Then you would enter in these blogs with black background, red font, right? And telling how powerful would you be if you had the IP address of someone or something like that. so kind of some stupid hint. There were a few serious websites, but most of them were kind of trying to be shady. I think that's why all these stock images about hackers is someone using a hoodie, this kind of thing. So my first security job by 2012 around was to work as a penetration tester. So shifting from developing the application to testing how secure are the applications from other companies, right? And you may think that it would be hard, right, to compromise an application, a server. And it turns out that there are so many ways. So many things can go wrong. The bigger the application, the harder it is not to fall into some trap and avoiding some validation here and there. So you have to be constant vigilant on that. So that was the attack part, right? The offense. And later I worked as a product security engineer, which is a profession focused on adding secure not only to the application, but to the infrastructure and also awareness to the team, everything related from bringing security from the beginning to the end of the product. So yeah, I think I have a bunch of years of experience doing all these things, both on the builder side, and the offense side, and also in the defense side.
So you have like a 360 overview from the building side of perspective and from the attacking perspective side, like a penetration tester, right?
Yeah, actually, it goes even deeper, right? I mean, my experience is most focused on those areas, but if you talk about security in general, then you also have people responding to the incidents, analyzing how the attacker got in. You have even further ramifications that I do have some knowledge, but I may not be an expert. I think dealing, for example, with the incident and secure operations centers very heavily on that.
Before we to jump into more technical discussion, I have a question which I like to ask. If you could time travel, would you travel to the future or to the past? For how far and why?
I love this question. So depends on the day.
I mean,
The day
today
where you
you
have
can just pick. You
yeah.
can pick past or future whenever you want. Where would you go, or when would you go, and why there?
Usually, just like any travel, if it's a travel to another country, I would have to have a goal in mind. That's more or less how I work. So if I felt very overwhelmed by technology today, I was somewhat curious to see how would be life without, TV, all these things. So I would go to the past actually. But I know I would get very bored. So I would be looking forward to travel to the future very soon. And it's a bit scary, especially with generative AI, how crap actually it can be in terms of not being able to trust content, videos, and things. But all the big questions we have in mind, will the human species survive, right? All this kind of thing. How will be the climate change in 50 years, 100 years? And what else are we missing out for the next century? I think it's very cool to answer these questions, right? So both sides would be pretty interesting to me. I would definitely, yeah, and if possible, I would travel for both to the past and to the future, then back. Would be just like traveling when people are in a cold region, they would travel to a warmer region just for the holiday and then go back. Some sort of mixed goals.
Great, I like it. So let's try to get a little bit of your expertise to the listeners, to the viewers, and start simple. How would you explain the differences between traditional DevOps cycle and what we call these days DevSecOps?
And basically, adding security feedback loops to the DevOps cycle, which doesn't mean just adding a security scanner in your pipeline. It's actually very much more broad than that. Add security to each and every phase of the DevOps cycle. And that's the core definition, I would say, core explanation. Then we can, of course, drill down to each and every step and talk more specifically about that. But it's basically to ensure that security is added in a way that maximize the security control, reduce the risk without adding friction or without adding much friction to the process. Basically, yeah, play together.
So this is just a broad, high-level definition, which we would like to dive deep into today. But there's a term very closely related, which we call shift left. So how does this fit to the picture of DevSecOps when you say that we all should shift left?
Yes. Security always it was always that department. You can think of a person, person that always came late to the party, right? So a company starts, They focus on making money and hiring a lot of developers, building something digital. And only after it becomes big enough or dangerous enough, then they say, oh, maybe we need some security to help us out. And when the security guy arrives, or girl, the first thing that they're already overwhelmed, right? So you already have hundreds, dozens of developers, a lot of code done, a lot of servers deployed, and then you were invited, hey, can you secure the whole thing? Just please, yeah, do it. So security had a tough time just catching up with the existing scenario. So you would start from the very right? So the end of the cycle, you would start doing penetration tests. You would start doing testing from the surface. You would start from the outside, from after everything is done, right? So you try to put off the fire first and slowly going to the point where you go to the source, where the code is built, the server is defined, and try to secure it right in the beginning, so to the left. And the industry has been focused on saying about shift to left, and the shift left they meant is about adding security scanners and testing your pipeline. That's already some shift left, but it's still stopping in the middle, let's say, because the real shift left is in the beginning, in the conception, in the design of the software. And the world is not there yet.
Mm-hmm. So you mentioned something, security by design. So it's something even more deep than just adding a scanner or making some additional checks at the code level, right? We may have static application security testing, dynamic application security testing, but if we go even more to the left, we can start with security by design. How can actually a developer that is building an application design it with the security at the first step?
Wow, that's the big challenge, right? How do you add security right in the beginning? I see some balance where when you have already, so just to take an example, you have an application that's already done, and then there is a SQL injection vulnerability there, and an attacker is already abusing it to exfiltrate data from your database. At this point, everyone can say, hey, there is a security problem, of course, right? But the earlier you try to identify a security problem, the more knowledge or experience you have to raise your hand and say, hey, I see that this is going to go to the wrong path. Which means that when you want to implement security by design, you have to have did a very good homework. You have to have some knowledge already to be able to spot the missed patterns or things that could become a problem to the later phases of the software development. Now, how to do that? First, you need to have you have to learn security, so you have to be already familiar with the topics to know what to look for. There's that. Second, it would be very helpful to have some sort of tool that would centralize not only possible requirements for security requirements for what you're building, but also potential threats to what you are doing, right? And then you have the requirements to address those threats. Security can get very complicated, so it can be very demanding to do this whole analysis. So it's very important to find a process that's lean and that gets kind of quick results that can help you in the design instead of taking a lot of time just thinking about the security part. It has to be something that is smooth enough to fit into the process. That's this main step. So having the knowledge, so having studied about it, being up to date with the news, looking at the history of your company for potential attack, compromise, and so on, learning from that, and having a way to, for any business requirement, be able to match with a security requirement. And for that is a big challenge in itself, how to find the right requirement for that dynamic business requirement. And you have tools and you have threat modeling frameworks. For example, Stride is a threat modeling framework made of an acronym, STRIDE, in which every letter represents a threat that you can use to brainstorm. And oftentimes you need a combination of all of these elements to get a good threat model of your application and then know what's the threats you're facing, what you're going to do about it.
Before we continue with our insightful conversation, I'd like to share something that I'm really proud of: the Web Security Dev Academy Bootcamp. I created this program to help developers like you deepen their knowledge in web security. If that sounds interesting, you can join our exclusive waiting list to be notified about the next launch and start receiving tailor-made security tips. This is not a usual online course, but group-based cohort training with my direct support. To join the waiting list, visit websecurity-academy.com. It's websecurity-academy.com, or check the links in the description. If Bootcamp isn't quite what you are looking for at the moment, there is another way to support us. Please consider rating this podcast on your preferred platform or leaving a comment on YouTube. Your feedback is incredibly appreciated and helps others discover our content. Also, if today's conversation sparks any ideas or if you find it useful, don't hesitate to share this podcast with friends or colleagues in the tech community. Your endorsement helps us reach and inspire more developers. Thanks for your support, and now back to our conversation. So what you're saying is that in order to have the security by design, we need to step back and start gathering security requirements by threat modeling, right? So this is something that happens before you even write code. How can you simply explain, and then we can go deep into more low level stuff, examples, but how essentially could you explain to a developer who is on the path to, I want to be more security oriented, let's say, right? I want to shift left. So how would you say to that person who has knowledge about the systems, has developed a lot of applications, but it's something new to them, when they say, oh, threat modeling, how can I bite this topic?
Right. So there is one guy called Adam Shostak, and he created a framework called the 4 questions for threat modeling, right? So what we are building, what can go wrong, what they're going to do about it, and what can we learn from it. So if you take all these 4 questions, and for whatever you are building, try to address those, it's already a very good first step. Kind of easy to memorize, to get started, separate 1 hour meeting to address these things, identify the potential threats, and then do something about them. That's the very beginning of that. So threat modeling is for just like business modeling. You have a model of what you think the business should do to achieve a certain business outcome. Then you would have the secure threat modeling, where you try to identify what threats would match the real world, right? So you create a model for that and try to address that in a cost-efficient manner, which is another challenge as well, right? So to get started with it, just caring about that your application can be compromised, having this knowledge that it's not something that only happens to what's in the news. No, it can happen to your application. So having this knowledge, first of all, there's the awareness that applications can be hacked. Then you start caring about that, right? So I want to be a security-oriented developer. First thing is, whatever I'm building, what are the problems about it? So how can you do that? So of course there's courses and so on. There's also, it's good to mention the OWASP, which is a non-profit, I believe it's non-profit organization, where you have a lot of projects inside them. So everyone would come up with a project and they would become a WASP security project. One of them is the testing guide, which is kind of a big PDF, if you will, with multiple types of attacks, how to test, how to verify if a given application is secure or not against it. So it was one of my first activities when I became a pen tester, was to read the whole thing. So I would start from that. Of course, there are lots of resources. Oftentimes, it doesn't matter that much from where you start, as long as you don't stop learning. But I would say if you just read the testing guide, that's one thing. Then for every project you build, you start with the 4 questions. You are already a big step ahead of the planet.
Okay, great. So we have 2 great tips right now. First is asking those 4 questions. Let's reiterate. You first ask yourself what we are building, what can
Correct.
go wrong, what we are going to do about it if it goes wrong, and what we can learn from it, right?
On the what can we do about it is more is just to add to this question is thinking how we're going to handle these threats. We can choose not to address them at all, or we can choose to address some. Others we can transfer. For example, if we're handling payments, you can you can try to do everything yourself, or you can, let's say, delegate to Stripe or something else. So then you are transferring the risk. That's different approaches on handling risk. But yeah, part just complement.
We will definitely dive into that in a more detailed fashion, but I just wanted to start with those 4 questions, which I really liked. And also, you mentioned OWASP testing guide, which if you read it and apply those principles, then you are also ahead in terms of the secure by design when you actually have in the back of your head those ideas in this document. Can you give some examples from this document that you remember just out of head right now when it comes to
Yeah. So
security testing
the
guide?
test, sure. The testing guide, you can think of a list of multiple possible attacks. Let's say SQL injection, cross-site scripting. Uh, I think also session hijacking. Maybe there's another name for it, but you have examples on how to test. How, let's say, if you have a SQL injection, given a URL, how do you verify if this parameter is vulnerable or not? What payloads can you try? And what are the response? How to verify if your attack is working, is not working, if the application is vulnerable, it's not vulnerable. That would help you to get a view on the attacks, but not yet on security architecture. But that's still fine for the first step. You just try to secure your code immediately, and then when we talk about architecture, we have other topics that come into the picture. For example, isolation. So nowadays, to give an example, when you develop some application, you would have customer data in the same database table, right? So you have multiple customers. So you create, let's say, a Calendly application where everyone can share their calendar there. Then you would have a table, let's say, users, and then all the users sit on that table, right? This is an example where if there is a SQL injection, one user can maybe leak data from another user because you have everything in the same database. When you apply secure by design concepts and try to make your application secure by design, so even in the case of even a SQL injection, something that's severe, right? You would be able to isolate the data. Imagine that every customer has their own database. So even if there is a SQL injection, they can only exfiltrate data about that customer in particular. So that's one example where you bring other concepts to secure a product by design. This type of knowledge is a bit more complicated to find in a guide, But once you know the possible threat and you're familiar with attacks, you start to add this to the design equation and make more informed decisions on how to do things. So the more critical your application is, the more sensitive, the more measures you would be likely to implement security measures.
You mentioned that Calendly example, like a calendar application, might have
Yeah,
potentially a table of users. And if you are really cautious about the potential SQL injection, you potentially may separate those users into their own database. But this comes with a cost, right? With many different costs, cost of the
correct.
infrastructure, cost of the development. How do you think a company or a developer team should or could balance between those measures that they implement? Like, okay, let's just throw a separate database for each customer, but hey, who is going to pay for that, right? So how do you balance this two extremes? Like, okay, we just optimize for time and money, but on the other hand, we need to optimize for security. So do you have any thoughts on the middle ground between those two extremes?
Yeah, so it's always a case by case analysis. It's hard to say there's always this way or that way. It depends on the risk appetite of the company. So by risk appetite is how much risk are you likely to accept in order to focus on the business outcomes. Some may be more cautious. Yeah, I wouldn't like to risk this. Or they would say, yeah, but we need to save the money. I don't care. Until I see problems arising, I would avoid all the security things. That's one way to think about it. Another way is to try to find the middle ground, which may or may not have extra costs. In the case of the database, for example, you may not want to do it for the free tier, but maybe want to do it for the enterprise customers. And that becomes a much more reasonable balance between security effort that you have to have for the sake of this example.
Okay, so let's go deeper and just could you walk us through an example of a threat modeling exercise for a typical web application that has user interface, admin panel, login, user panel, some CRUD stuff. There is some database. How would you go through a basic threat modeling exercise in such a typical 2024 web application?
Right. Well, every single piece you mention, so there's the login, the admins, already pops up a lot of threats, a lot of requirements. I mean, a lot. But if you take, let's say, if you start for the login page, I guess most common, every app has to have one, right? Or today you can try to mitigate most of the risks by using some authentication providers. So you let them handle all the risk about storing credentials in a hashed version. But you still have risk that you cannot delegate, for example, session management. Even if they authenticate in another provider, they would still need to have a session that you have to store as a cookie somewhere in your application to represent that this user is logged in, right? And so let's say if you're using Auth0, then they would give back you a token, but where do you put this token? Depending where you choose to store it, you can put it in a local storage, a session storage. And Auth0 provides their own SDK in this case, so they try to even solve that for you if you use their library. Now you have another risk, let's say. Although they're solving it for you, you have increased the risk in the supply chain, right? Now you have a third-party library that has, if there's some, let's say, Auth0 is compromised, Okta is compromised, then there is a chance that someone can directly impersonate and log into your application, right? And there's also the other problem where problem depends how you see it, but that you have a dependency from them in your app as well. So they're not only a provider, but they also provide dependencies on your application. So what would be the impact if such provider is compromised and wants to target your application? They basically can do everything, right? Allow anyone to log in as they want, because you are sharing this risk with them. So while this is acceptable in most applications, because you take a trusted provider and you hope nothing happens, right? If you're talking about critical infrastructure, relying blindly on third parties may be a problem. Suppose you have a button where you press and it turns off the whole electricity of the city. You may want to add more security layers to that, right? To reduce, in this case, supply chain risk. So, well, just going back to the question, we would try to map all these things. How many dependencies you have? How are the suppliers? In my case, many things are already kind of come from my head because I know what would need to be prioritized. But if I didn't have this experience, it would become more. It's hard. You have to have someone with some knowledge to lead the threat modeling session. That would be able to pinpoint things faster. There's that. So if you take a logging application, you would first go down and understand the business requirements. So does this user need to be logged in all times, or is just one session? We need to remember their device, right? What information are we going to handle in this application? Is it public that everyone can access? Are we talking about PII, so personal identifiable information? Are we talking about health data? So depending on the data, we need more or less requirements for the authentication process, right? Which is delivered by the login page. The login page actually means many things. Not only the authentication process, the device authentication, session management requirements, also authorization requirements, which will be heavily tied on how you architect authorization to work across your microservices. So there's a lot of things to unpack. Indeed, it's hard to do everything very quick. You need to take each and every component, drive the threads, the requirements, and yeah, it's a lot of work.
So something that actually I feel in your response is that it's not that technical, but it's more first understanding the business requirements. What data do we have? How they are going to be used? Is it health data or not? Is it do we need to store it here and there? So it feels like in order to even start threat modeling, you first need to be very knowledgeable of what kind of business are we actually doing in this application. Is that correct?
Yes, 100%, yes, because security is meant to protect the business. And the first thing is to understand the business. So you map the risk and you try to add controls to mitigate risk where appropriate. And the implementation of these controls can be can demand time and effort and money, right? And security job is to balance that, to amplify the security in the process inside the company, and and be there to really help them on making the business go live faster with the right amount of security measures. So you have to understand the business to do it right. You can do it
So,
wrong,
so
but
this
to do it
actually
right.
relates to this actually relates to the first question of those four, which you mentioned before. That the very first question, what are we building, right? So this
Yes.
actually addresses this first step, right? That we first need to really understand what is the business about. So secondly, you mentioned that you need to look at each and every component in the system and try to find potential risks, right? So we mentioned login page, we mentioned admin page, right? So we are trying to think of what potentially can go wrong. Can we call this step like at the fundamental part of this threat modeling, when we actually trying to ask a question, what, looking by each component, and narrowing down our focus, uh, looking at the given component and asking ourselves the question, what can go wrong here, right? Is this the core of threat modeling?
What can go wrong here? Yes, that's the core of threat modeling, I'd say. It's to, based on the business model, derive the threats out of it. And what can go wrong is really the core, but to get that, you have this understanding before, then you have this handling afterward. And to also complement the first question, what are we building? It involves many elements to answer that. So one is the business requirements, or what we want to do in business side, but then you also have to include technical aspects to the answer of this question, such as what's our tech stack, what's our architecture diagram, what's the data flow diagram, what type of data we are handling, what's the sensitivity, what are the integrity requirements, availability requirements, so on and so forth.
Mm-hmm. So the second step is actually understanding the potential risk. Do we have any frameworks on mapping out those risks in the industry, or it's just everybody can do it on your own? Just take a piece of paper, draw a diagram. Okay, this piece can be SQL injected. This can be cross-site scripted. I mean, is there any framework or a guideline on this step? When you let's assume we understand the business, we know what we are doing. Now we are looking at each and every component and trying to just brainstorm what is potentially possible in this case, or in this component of the system. What can go wrong? Can we somehow systematize this process?
Yes, that's why I founded the DevOps.security. Because that's a big problem. Uh, what happens is you have a bunch of possible attacks in one side, you have the business requirements on the other side, and then you have to try to find what's applicable and how it is applicable. Because if I tell you you need to defend against SQL injection, there's more than one way to do it. And how should you do it for your own reality, right? This is a different question. And it's proving a challenge. So you have, for example, database of threads, and you have WASP resources. But to make this link, usually people would use threat modeling frameworks for brainstorming. There's Pasta, and I think Stride is the most famous. So Stride you would take for any given, so you suppose you have a diagram here of an application that connects to a database. Then you would try to apply Stride. So is there a risk of spoofing the connection between the application to the database? Which means, can we fool the database as if we are a different application to try to get this access? Oh yes, there is this threat. How do we mitigate? We mitigate it using authentication. We ensure that only that application can talk to that database. For that, we need to create a user and password for that application. So even though we usually don't think that much about it, we need some credential to the database. But we are behind the scenes mitigating the threat, right, of spoofing between the database and the application. There's and then you try to go to the next letter on the Stride acronym. So tampering. Can we tamper, let's say, the data that is being sent and received between the application database? Or can someone tap into it and modify, be an adversary in the middle, as they call it? Before it was man in the middle, but then we have new terms because it's have to be gender equal. So everything changed. They had to update the whole WASP. Now it's adversary in the middle. And to prevent that, you would need to use, for example, TLS in your connection of the application and the database. So even if someone tries to modify the connection, right, it wouldn't work. So then you're mitigating tampering. Then you go to the next, repudiation. Uh, and then you go for each and every component, for example. So you may need to add letters to it to help on brainstorming. Sometimes you already have a security component you can reuse it. Someone did that threat modeling, we just trust based on that. Because if you try to threat model everything to the server, to the processor you're using, you'll not have enough time to finish the project.
So then we covered S, T, R, and then we have I, D, and E. Can we dive into that?
So yeah, actually there's the R for repudiation. So one common example is when you can do something and you can't actually prove that it was you. So usually mitigated by, let's say, digital signatures, where you can uniquely identify that someone did a certain action. So it's you have to see if it's applicable to everything here. So for example, if someone did a query on the database, do we really need to prove that it came from that particular application? We have authentication in place, but we don't have, let's say, stronger measures than that. We could, but then usually you don't do that for the application database connection, right? You just stop at the credential there. The I would be information disclosure. So would that be applicable? Then say, yes, someone intercepts the connection, they may be able to leak that. So you use TLS again. So this is mitigating tampering and mitigating information disclosure. Then you have D for denial of service. Can we knock down that database? Oh, yeah, so there's a thread. Maybe you need read replica, an additional instance of the database so you can prevent it from being, knocked down, which would impact your application, right? Then you have E for elevation of privilege, which was initially meant for desktop application as becoming the admin user. So you would brainstorm scenarios around that. What you can think of, can my user suddenly becomes the admin user of the database? So you may say, maybe there is this threat. So one way to mitigate would be to keep the database up to date to avoid if there's any sort of known exploit about it. And kind of comes related, but not that much. You can say, let's first of all ensure that our application is not already using the admin account. Let's give a more limited user with limited permissions to do this query.
Mm-hmm. Great. So the takeaway for the developers listening to this show in this case would be, when you want to start with this threat modeling step number 2, when you are trying to brainstorm what can go wrong here and there, you can use STRIDE, an acronym helping you to ask proper questions, and it goes for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. So then you can actually use those parts and categories to, sit down and try to find out what potentially can go wrong. And then we have this next step. Uh, Once we mapped out the risks, then the third question was, as far as I can remember, okay, we have identified what can go wrong, and then do we have this kind of, I don't know, an Excel sheet of those lists, or do we have some kind of other place where we store them? And maybe it's just a project documentation when we have this. And then to each and every risk, we are trying to find a mitigation technique, right? So, for example, you mentioned for the information disclosure, we may use a TLS, right? So is there also something standard or some guidelines on this step number 3, when supposedly we know our business, we know what can go wrong each and every piece of the system or every component here and there, and now we are on the step 3, when okay, how can we address each and every, because I really like when you say that sometimes we are deciding not to address the risk, or sometimes we are deciding to transfer the risk to another party. So how can actually developers act upon this third step? Because I just mentioned a couple of ideas like transferring, ignoring, or addressing. What is your take on this third question?
Yeah, so I wouldn't repeat. Uh, that's why I also founded the DevOps.security. But here's the thing. Now it comes down to the risk appetite of the company. Now now it's going to become a matter of effort and money, right? So whatever choices are, we want to fix this and that. It's going to someone will have to do it. Someone will have to verify it, right? Now you identified. So just like let's go back one step. As we identified the threat, so we identified the spoofing in our service, for example. Would you like to add a new instance of the database? There is a cost associated to that. So this trade-off has to be analyzed in this third question. What makes sense for us, what we have in the budget, how critical this threat is for this given scenario, may make sense for this application, may not make sense to other types of application. So just how solve that in the product and the platform. Just saying this because this is a kind of a general usage, general, let's say, takeaway you can take from it. If you have more information about the context surrounding the application, so what was the business goal meant, if you have a way to correlate it easier, you can, in a more, let's say, efficient way, determine what rules, what decisions have to be done for some particular group of threats, and generate a security roadmap of what you have to address in the short, mid, and long term. So instead of thinking what we have to do now or never, kind of black and white thing, it's better to spread into what we have to do now, what we can do later, or what we can do after a given change in both business requirements or threats. So let's say if the requirement changes to that, then we would need to implement this kind of predefined trigger.
So basically, you're saying that it's not like a 0-1, it's more like making a priorities based on those risks that we identified in the brainstorming session, and then take it step by step, something that may require immediate reaction, or something that may be done in the future, something that doesn't need to be done, or we just decide to off-site this risk, right? And actually, as you said, it actually depends on the risk appetite and the budget and the profile of the company. And the last piece is that the feedback loop, right? So is this does this only mean that we really need to experience some manifestation of the risk in order to make an educated step in order to improve? So how does usually happen in your experience, this last step, that okay, what can we learn from that? Does it really need to break in stuff by someone, or this feedback loop can be less dramatic?
Less dramatic, yes, totally doable. One I like Adam Stake, so the guy who creates this framework. He says that if you just ask all the people involved in the threat modeling session if they would recommend a friend going through that for the application they're developing, would they recommend it? If they do, it looks like you're in the right path, right? If not, why? So what was wrong with the process? Are they being inefficient in collecting, understanding the business? Is it not very structured or very clear, the process of identifying the threats? Or on the third phase, what you're going to do about it? Is it hard to decide on what to do? What's not working out for all the previous steps is what you consider on the fourth. So what we did so far, is it adding value to the business? Should we continue to do that, or is something missing? Because when you reach this last step, you already went through a lot, and that's the time to improve. So for example, if we have to develop a second application now that uses a database, can we be faster in deciding identifying the threats and deciding what action we should take about them? Or no, that this is the maximum we can make it efficient, let's say.
So it doesn't really mean that there could have been some uh, exploitation or data leakage. It can be less dramatic and just asking a question. Okay, we did we did that, or we didn't do that, and should
Yes,
we change it? Should we improve it? How did the implementation go, or something like that? Do I understand correctly?
correct, 100%. Yes, it's about if even if you take some non-security related things such as a PDCA, right? So plan, do, check, act. This whole idea of self-improvement, that's the core of this question. How can you make the process better, faster, stronger, right? Uh, for for the next iterations, because threat modeling is not meant for you to be. It looks like, as I mean, we're talking like sort of a waterfall fashion, right? So you have all the requirements, then you have, but you can also apply this definitely and should for every sprint add an iteration to update the threat model of your application, especially for major features. When you have something new that you're going to provide, requires a lot of change, requires a new security assessment of those changes that goes through the threat modeling process. That's a subset of the security by design. I mean, yeah, we talk about training, we talk about threat modeling, can also talk about security by default, kind of having trusted shared libraries across the company. That's also a very good initiative. Reduce supply chain risk, and yeah, basically creating things to minimize the chance of finding problems on later phase of the software development lifecycle. Because
Mm-hmm.
today, the application development is they start with what they think is good. I mean, just out of their head, and that's all. And then they'll send the codes to a secured scanner and hope that the scanner will teach them what has to be done. That's more or
Mm-hmm.
less a good maturity level.
So,
Medical.
so if we don't want to end up in the position when we are building something and then be on this right side that okay, we have built it and now we need to test if it's secure. So how can developers easily integrate security in their DevOps workflow without actually slowing down the development process? Because this actually comes with some kind of cost, right? You have to do something. So what is the low hanging fruit when it comes to adding the security in the DevOps? Not being in the position which you mentioned that we build it, then we test it, but we want to make this shift left. And what can be this easy step to be in this more DevSecOps rather than DevOps?
So if you have nothing, right? If you have nothing, you're starting from scratch and said, I want just the low hanging fruit. So we have already today's sponsor is Nick.
Yeah, I'm a Sneak ambassador, so I know this great software that integrates into the pipeline. But I want your take on that. You think that one of those approaches would be integrating some tools like Sneak into the pipeline, right?
Yes, so definitely is a quick win. But someone has to review these findings, right? It's not, they're trying to create out of thick things. So you have, for example, the Pendabot. I think it's a very good quick win. As long as your application has good tests, that, because if a machine is committing and merging to your code base, you don't want to leave everything to chance, right? You have to have good tests in your application. Then you can have this automated pull request there. And I think this is going to be the future, but we're not quite there yet. So the two quick wins I can think, three, I would say. Something like the Pendabot for dependencies. It's a very good quick win. A lot of compromise are due to outdated dependencies. You have, for example, ImageMagick that performs several operations related to image, but if there is an exploit to that, they simply have admin in your machine or something. It have buffer overflow because even if your application is not using this more high level language, let's say, if you go to ImageMagick, I think it's using C or something. So I don't know. Not every dependency is the same, but some have more risk than the others, and you want to reduce that. So, and one of the ways is having something like Dependabot, Renovabot that would update your dependencies. Second is have a scanner for your code. Depends on the tech stack, depends on accuracy, depends on a lot of things, but have something. Start out. Doesn't need to be perfect. Start out with something. Learning. Enroll people in some courses, make sure that they know the security concepts. That would help a lot on designing architecture, updating the architecture of the application. So you can do this simultaneously. So focus on learning, focus on adding these quick wins on the pipeline, and try to. Okay, so this is the very first step. Second step, add a threat modeling discussion to your to your sprints. Allocate 1 hour time to discuss special security impact of major features. That's a very good second step, I'd say. And this can also be potentialized with tools, right? There is that. So that's as a vendor, that's where I come in. So to help accelerate this part of the threat modeling to reduce the time. So let's say if you need to spend less time on the research of the requirements, less time on the matching, and having already a standardized way across teams that you can enforce the same security process. Because one problem you will run when you have a big company is every team will start to do things differently, right? How do you centralize all this effort? And that's where a threat modeling platform helps to unify this and give a view to the security team for them to support the development across the whole company. So first step, pipeline, SCA, so a renovable, dependable, and training. Second, add a threat modeling session. Third, standardize it across your company.
Perfect. So these are a couple of quick wins that every developer can actually take away today and apply it tomorrow at
Exactly. Apply
their
today.
projects. Or even today. But I assume that someone is listening to the show after work day in the evening, maybe walking and chilling
Work
out,
hard.
and and then the next day during the stand-up session they come up with those ideas. That can be awesome, really, to hear those stories happening in the projects of our listeners and viewers. My next question would be more to types of threat modeling. Can we tell that we have different kinds of threat modeling, like manual, automated, and then scaled threat modeling approaches?
Sure. We kind of touched these topics across the answer, but to get them together here, the manual would be when you try things more ad hoc, with something more basically on your experience on top of your head, something that you kind of saw. It's not a structure, or let's say reproducible in the development language, right? You would like it to be reproducible. So the first usually start with something. It's great. The start doesn't need to be perfect start. So it's unstructured. You think, oh, it could go wrong. What do you think? What do you think? What do you think? We have something. That's great. First step. Second, how do you make it more structured? All right, we can use the Stride framework, just like we checked out today. We can also incorporate, we're in the PCI part, we can also try to incorporate, the requirements from PCI to our threat modeling, and also use them to brainstorm. So you have structure there, cool. And then on the third is to make it structure across the whole company instead of everyone doing their own thing. So even if it's structured, it's not yet standardized. So standardized would help teams to benefit from the work of other teams, so everyone can be more efficient.
Mm-hmm. So we may have something which is unstructured, structured, and then standardized, right?
And scale.
So coming back to more technical stuff, what do you think are most common security vulnerabilities that developers need to know right away today? Can we just point out a few things that you think are most deadly to the organization?
I'd say that the most deadly starts by using outdated frameworks. When you access a website and then you see a .php, I mean, depending on the website, it is okay, it's still using a framework, but some other applications, they are not using framework at all on the server side. And it always strikes me as something very dangerous, because the modern frameworks take care of a lot of things for you, not everything, but a lot of things, such as an ORM, so you can connect to the database, do secure queries, right? Passing the permits without interpolation, can protect against SQL injection. So when you use modern frameworks, there is a less chance of misuse, and that's what you want, less chance of things to go wrong. That's the first thing. The second that's very, very common is data validation and authorization checks. I mean, maybe authentication, authorization, and data validation. So these three things. So authentication is, there are so many ways that can go wrong. But so when you go to an authentication page, it could be, you could try brute force, you can try how weak the forget password mechanism is. So if you delegate it, let's say if you know nothing, delegate it. If you know what you're doing, then you can build your own. But if you don't know, it's better to delegate, because there are so many things that can go wrong when in this critical process of authentication. Authorization, very, very common, where you can, as a user, read an object from another user because you're not checking if they're from the same account. So this is something that you sometimes it's not easy to come by default in the frameworks. It's between users, between tenants, and you have to implement your own logic. And that's where things can go wrong, because everyone do it their own way, or they don't do it at all, or they forget in some instance and remember others. Everything you have this chance of doing it incorrectly, it will eventually be incorrect. So authentication can delegate if possible, authorization checks is always that. And the data validation, I mean, sometimes we get lazy, right? We want to use MongoDB, put everything there, and eventually we'll validate things, right? But if you want to have a secure app, you have to know what you are expecting from a request at all times. So you would know which parameter, what's the class, right? What type you're dealing, what's the max size, if you accept null, if you don't, and be very strict on what you accept from the request, because there's a big chance of it coming to bite you, even in second order application. So in this application, it just stores the data, does nothing. But then another application takes this input that's vulnerable and process and triggers a SQL injection in the second application, as it's being forwarded as untainted and malicious payload across your system. So data validation is very important. It takes a lot of time. It's very troublesome, but you should not skip it. Really.
It reminds me when you said that you have to validate, always validate, and type checks and different potential inputs. It reminds me of GraphQL being very, very restrict when it comes to the format, when it comes to the types, and the way it approves or disapproves the requests in this fashion that. It's not, just a simple thing that you send over the wire. It has to be very, very structured, and very much of it is getting then processed through various, validations, because GraphQL relies on the schemas a lot, and it actually is something similar to SQL, but not between the backend system and the database, but between a front end and a backend system. On one level higher, you are actually using schemas and structures. But on the other hand, if we compare it to SQL, SQL injection is one of the most common issues or risks in the software on the web, right? So it's not easy, I would say, to always have one single solution to given vulnerabilities, but be aware of the types of the given vulnerabilities and actually tailor it down to your particular tech stack, to your particular business, right? I would ask you one final question during our conversation today. Do you recall some spectacular or dramatic situations in the companies or organizations that actually experienced some exploitation that you actually saw very close with your hands-on these situations?
Very dramatic. From where I've been, so when I worked, say, in big companies, they may have been hacked before. There's that. Heavily dramatic. So, as in responding to an incident, a hack. No, I haven't on this part, but I had colleagues that were in companies that were hacked. And that's kind of bad, right? Imagine the company is being hacked and you work in the security part. How do I explain that?
So it is not me, but I know someone who has been there. Trying to see.
In my case, in my case, seriously, what I do, maybe have more to tell is when I worked as a penetration tester and I was the one finding those bugs.
Okay, this can be an interesting example as well.
So one of I remember. So we talked about SQL injection, but there are different types of SQL injections. One of them is the blind SQL injection, where it's the SQL injection, like the one but you don't have access to the output. If there is a syntax error in the desk, you don't have this. You have to use other things to measure if your attack is successful or not. For example, using time. And I didn't know it was I didn't know there was this the name for this, that it was a separate type of attack. But I knew it was possible because I knew SQL and I was working as a penetration tester. And I thought maybe there's something I can do it, because when you're going to test the applications, you find weird limitations because so this parameter only accepts 100 characters or 20 characters, and you have, but it's vulnerable, but it has to fit this stupid size for that application. No? So the text, sometimes you have to be creative to make some stuff work. So I remember, finding SQL injection, quite a few of applications back then, and it's dramatic when you have to present it, because you have to say, hey, the application, we're doing the test, we're testing this, but we're testing the production version, and the production is vulnerable. So you have to really call them ASAP and say, hey, there is a critical, you need to fix it right now. And they do, I mean, they do fix. But that's the company thing. I'm saying there is a fire, it's in front of you, and it will burn your house. That works. So now they consider it as important.
You
If you say
said
there's probability
ISMP?
of fire, sorry.
Did you say ISMP? You sent it to the ISMP. I didn't quite get the name of the
No,
place where you
sorry,
sent
no.
the
I just
incident.
sent to the customer. I
Okay,
don't know.
I,
Maybe I
I, I, I
misspoke.
thought I heard some kind of
Acronym. Maybe.
acronym. Maybe you just said ASAP, that it has to be as soon as
ASAP.
possible.
Yes, exactly. Sorry. Yes.
Yes, you said ASAP, like as soon as possible. I just misheard it, and I thought that there's kind of like interesting acronym which I didn't know yet
We
about,
have
and
so
I
many.
wanted to follow up. But I think everybody knows ASAP.
We have so many acronyms that I think it's very problematic. I think we have CSRF, XSS. We have SQLI. We don't even say SQL injected, SQLI, so it becomes another acronym.
So we are touching an
And it's so
interesting
many.
problem. It's an interesting problem that you have XSS, right? ASAP, SSRF,
Exactly.
or SQL, and many others. And especially when you are just talking, not looking at the letters, it may get messy when you want to understand. Like in this case, I really thought that you are coming up with some acronym that I thought myself, like, oh,
Yeah.
did he just say some acronym for, I don't know, security, incident response team management, something like that? And I just wanted to ask you on that, but it was just
Yeah.
plain ASAP. And then
Yes.
you mentioned that you
Yes.
found in production. You found in production a critical SQL injection just because some limitation in the characters, and probably when you mess up with this you can just exploit the table or do some other messy things, right?
There's
Is there any final thought that you would say apart from learning this stuff to developers, that they can just maybe some quote, maybe some thought that you can share with the listeners, that they can just leave the show today with this in the back of the head? Because for me, I really like those 4 question framework. Let's reiterate it. Is that what we are building, what can go wrong, what we are going to do about it, and what can we learn from it? So to me, this will stay and stick after this conversation. But maybe you have something that you want to share to the audience.
Yeah. So regarding these 4 questions, I built the exact tasks you can do to answer those. So I created threat modeling one pager as a PDF one pager. Maybe I can put the link somewhere
We
in
can
the
put the links in
description.
the show notes
Yeah.
for the people to see.
Great.
You mentioned it, one pager, right?
Yes, exactly. So that has all the text on how to answer these questions in a very detailed fashion, but one page to make it simple. Uh, wow, there are so many different aspects to security that I think it's a bit hard to give one single message. For example, there's the people that wants to learn more and want to specialize, maybe get a job. Then there's the other that wants to protect their application right now, what they need to do, right? There is the other just curious on exploring what's in there in security, because you have mobile security, you have a red team, you have blue team, you have people specializing in identity. How can you have a professional, right? Focus on IAM, identity and access management. I work with that, but you may wonder what would you do working with IAM, right? Isn't that just a login page? Why do you need a full-time employee for that? Sometimes it's hard to understand the complexity behind these things. No. What I would say is, as long as you care, I mean, or you have a reason to care, and you remain curious, you will be able to find your way pretty much in everything in life. So as long as you think, given today, especially ChatGPT, there is no excuse not to be able to find your way if you want. Because before we would say, let me Google that for you, maybe that's websites where you can take a query. So back then you have questions, then people would go to forums and they would ask questions like, what is PHP, right? And then someone would say, why don't you Google that? And then there's the link, let me Google that for you, that when you click, it would open a Google page and type for you something about PHP, what is PHP? And then you see the results, right? But today with ChatGPT, it's even worse, or even better than that. You just say what is, and it answers, and if you don't want to read, wow, wow, there's no hope, right? You have to want. As long as you want, you'll find a way. ChatGPT, just to also to maybe clarify that. How helpful can it be also in identifying potential problems for your applications? It's both good and bad. So it's good that it helps to give you some overview, but it will always try to make that overview condensed because it has a context window. And it's not up to date to point you to the right projects that you need, because it indexes a lot of things, and some projects are more useful than others. If you look at in practice and what ChatGPT has indexed, so there is a gap there. It's definitely better than nothing, but if you want something more robust, it just can help you if you use it on the raw way. Uh, it definitely can help, but it won't do everything for you. It's great for the first step. So if you have these 4 questions, for example, it can help you be your brainstorming partner for that. So I would say we don't lack resources nowadays. In technical resources, we have, of course, time and money. But for everything we want to do, is just a matter of creating a structured process, avoiding the anxiety of trying to do everything at once, because the more time technology evolves, the worse it becomes for everyone, right? So the Z generation is highly anxious because we basically fucked up on evolving the technology and created anxiety for everyone. So yeah, just keeping calm, structure things, using what we have, getting started, and improving gradually, and yeah, that goes a long way.
That was a very interesting conversation, and thank you for joining. And until next time, thank you all. Thank you, Anderson. Thank you, our great audience.
Thank you for having me.